Today we're going to look at combinations and how they differ from permutations. As I said earlier, the combinations and permutations really, if you do it with our arrangements with repetitions, life becomes relatively easy. I cover this because we are going to be asked some questions on permutations and combinations on the exam. Now, we talked about permutations yesterday. We talked about the notation, n perm r, or what I use, n pick r. We had a formula attached to that, n factorial minus n minus r factorial. So what this would be is how many arrangements of 5 objects can I make from 100? Now, we have talked about that. Arrangements would be 1, 2, 3, 4, 5, and then everything else is not chosen. So the arrangements with repetitions can be used for this, or we could do that same thing with 100 pick 5. So this would be 100 factorial over 95 factorial. Again, I don't care which one you use. In truth, I would go 100 times 99 times 98, 90 times 97 times 96 most of the time, and use neither of these because we are talking about arrangements. So that's not what I want to do. It doesn't like me at the moment. So this here is an arrangement. Group of 4 students, 3 are to be elected to an executive committee with specific positions. First person gets the most votes, gets the presidency, second gets vice president, third gets treasurer. So does order matter? Yes, because we have I'm going to say number of votes besides the position. So I'm using votes in this case, but the first person chosen is going to be the president, etc. So the order is important. This is an arrangement of objects. We talked about the different ways. We have there's 4 people to put in the first position. Now, after we put the first position, now we have 3, and finally we have 2. So we have 24 different ways to do that. We could also do this as 4 perm 3, which will give you 24 ways. We can stop moving. Okay. So, like I said, there's 2 different ways to get this, an arrangement. I could also brute force it. I really don't want to write out 24 different ways of doing this. Now, let's change the question that the 3 students are selected to serve on a committee. In here, there is no positions within that committee. So does it matter if I choose Rory first or Sean first if they're all going to do the same job? No, they aren't. It doesn't matter at all. So order does not matter because they're all equal in a lot of ways. So in this case, equal terms of if it's a committee, they're all doing the same job or they're all prepared to do the same thing. So that one is not. Now, let's brute force this, where if we have 4 people, Ann, Bob, Charles, and Dave, how many different of these guys, how many different committees could we make? Now, here's a term I'm going to use a lot. How many groups of 3 can we make from these 4 people? Well, we could have Ann, Bob, and Charlie, Ann, Bob, and Dave, Ann, Charlie, and Dave. Then we could have Bob, Charlie, Dave. There's no other groups because it doesn't matter if I do Dave, Charlie, Bob. They are still the same group as Bob, Charlie, Dave. So now we have 4 ways of grouping these guys, grouping three people from 4. Now, how do we get from 24 to 4? Well, we divide that by 6. Now, we can do the 20, we can figure out the 24 by 4 by going by going 4, pick 3, and 6 can be written as 3 factorial. Okay. Now, this is going to lead us to the formula. What we have here is we have 4 factorial over 4 minus 3 factorial over 3 factorial, which 4 factorial over your 4 minus 3 factorial, 3 factorial with a little bit of algebra. So this is a formula that we're going to use in the future. And you notice we're just dividing by, again, the number of objects that we are arranging. And here is our groupings. Okay, we have, if we're talking about ABC, this is ABC, and then we have ACB, BCA, BAC, and CAB, and CBA. Those 6 all group down to ABC. They all include the group ABC. Now I'm going to see if I can do this. Change color. Then we have ABD. There's ABD, ADB, BDA, BAD, and DAB, and where's my other one? DBA. Those guys all reduce down to ABE. Then we have ACD, and we have DCA, ADAC, and where's my other ones? Okay, we're over here, CAD and CDA. Those all are ACD. Now the only one that we're missing is this group's all taken up, we've circled everything. We have BCD, the groups that are going to be collapsed down to BCD. We have BCD, BDC, CDB, CBD. Those guys all collapse down to the group BCD, if order is not important. So every one of those ones I had circled in green, doesn't matter if I selected D first or B first. They all have a group of BCD. So here we have our 4 combinations. Here are the 24 permutations. So what we have, as I mentioned earlier, we can take the number of permutations for 3 objects from 4 and divide it by 3 factorial. In this case, if I want to do a general, the formula for n choose R, or n combination R, I use the word choose. It is the number of permutations divided by R factorial. So number of permutations was n factorial over n minus R factorial. We're going to divide that by R factorial. And we're dividing a fraction by a fraction. So n factorial, n minus R factorial times 1 over R factorial. So that is the formula for our combinations. Again, this formula, just like the permutation formula, is given to you on your formula sheet. Without technology, we're going to use this formula to plug in 5, choose 3. So this is going to be 5 factorial over 5 minus 3 factorial, 3 factorial. 5 factorial over 2 factorial, 3 factorial. Expand your 5. 5 by 4 by 3 factorial. Those guys are going to cancel off. This works out to be 10. Six, choose 5. Same thing. Let's make that smaller. 6 factorial over 6 minus 5 factorial, 5 factorial. 6 factorial over 1 factorial, 5 factorial equal to 6. And you should notice that this looks an awful lot like what we were doing when we were talking about arrangements with repetitions. Some of our problem solving, that was the answer, or this was the answer. And then 10, choose 8, exactly the same thing. 10 factorial over 10 minus 8, factorial 8 factorial. 10 factorial over 2 factorial, 8 factorial. 10 times 9 times 8 factorial over 2 times 8 factorial. Cross off. What we end up here is 90 divided by 2 is 45. So, again, there is a button for that on your calculator. It's under math. So if I wanted to do that 10, choose 8, I would go 10, go back over to probability and down to the choose, and then I would go 8. Now on the older models, it's just going to be 10 C8. Here they have it it has the 10 and the 8 as subscripts. We end up with our 45. Now, again, we have the exact same problem here that we would have had in arrangements with repetitions, or we could solve it with arrangements with repetitions, but we're going to solve it with combination notation. So the reason why I know we can solve this with combination notation is we don't discuss order. There's no arrangement. We are just making groups of people to meet with the principal. Okay, so we have 30 people in 2 different categories that may come up in terms of the problems, and we want a group of 5. So arrangements with repetitions, we would do that. Meeting, and then 25 lucky people, 30 factorial over 5 factorial, 25 factorial. That's the answer. We're going to get the exact same answer with combinations here. We have 30 people. We are choosing 5 of them to go to the meeting. Okay, why is it choose? Nowhere in this question does it mean that the first person is going to speak and then the second person will take notes. There's no real reason why we would have to arrange this. This works out to be 30 factorial over 30 minus 5 factorial and 5 factorial. I seem to have messed up again here. That just drives me nuts. 30 factorial over 30 minus 5 factorial, 5 factorial, which we have over here, although the order that I did it was a little bit different. We're still going to do the same process that we do before. We have 2 males, 3 females. So we want to deal with the males, and we don't want to deal with the women. So we have 18 guys in the class. I'm choosing 2 of them. Okay. Again, no matter, no order is important, so we get to use choose. And then I'm going to pair each one of those groups with this one, which is going to be 12 women, choosing 3. So that is in combination notation. We can then use the combination formula to get what we would with the arranging with repetitions. Would be 18 factorial, 2 that we choose, 16 that are lucky. So again, 18 factorial over 18 minus 2, which is the 16, and then the 2. Times that by 12 factorial over 10 factorial, not 10 factorial, 9 factorial over 3 factorial. It'd be wonderful if my eraser would work. So when you get a question like this, whether you use combinations or whether you use the arrangements with repetitions that we've already spent a fair bit of time on, it doesn't matter. It gets you to the same spot. You notice that this equation is what I've got over here is exactly what I would have if I used arrangements with repetition. Brooke, the principal's daughter, must be on the committee. How many committees consist of 2 males and 2 females? So we're going to deal with Brooke. That leaves us with 11 women, because we've taken Brooke out of the pile of women, and that still has 18 men. There's one way to put Brooke on the committee. We have 11, choose 1. We have 11 women to choose from. We have 1 more woman to put on the committee. 18, choose 2. How many ways can we put 2 men? 2 men from 18. Now, if Steve and Ann can't both be on the committee because they just broke up, okay, fine. How many committees of 3 women and 2 men are there? So again, we have to break this up into Steve and Ann, which leaves us with 11 women, and it leaves us with 17 men. Now, they can't both be on the committee. When we think about this, we have both, 1, or none. So since they both can't be on the committee, we could have these 2 choices. Either neither of them are on the committee, or none of them are on the committee. So we have 2 possibilities that we're going to have to add together. So to put one of them on the committee, there's 2 ways to put one or the other on the committee. Okay. Actually, we're going to have, this one's a little bit more difficult in that because it's not just 2 men. We've taken them out of both categories. So I have to rethink this one. So basically, we're going to have to do Steve on the committee, Ann on the committee, and neither on the committee because of the way this works out. So there's one way to put Steve on the committee. That means we're going to be choosing 3 women because Ann is not on that committee. So Ann's left off, so I need to put 3 more women on that committee. And then I have 17 men, and I'm only putting 1 more guy because we've already got Steve on the committee. We only need 1 more guy. we're going to add that to one way to put Ann on the committee. What we have here is now we have 2 more women that need to be put on the committee. And this is why we had to break it up. Because depending on who we put on the committee, we have to change this. And then we have 17 guys to put on the committee, and we get to choose 2 of them. There's one way to put neither of them on the committee. And then we're back to 11, choose 3, times 17, choose 2. And we would add all those together. Another possible way of doing this would be take the total minus both on the committee. This one actually is a lot easier in this case. As you saw, I almost went and did it wrong. I started the wrong process. The total, we already did, 30 factorial over 30 minus 30. Let's use the right notation. 30, choose 5. Now, to put both of them on the committee, there's one way to put both of them on the committee. We have 11 women. There's only 2 spots left because we put Ann on the committee. That leaves us with 2 spots. Times 17, choose 1. Because there's only 1 spot left for a man because Steve has already filled one. So we got Steve, Ann, we got 2 spots left for women, and we got 1 spot left for the men. So this one definitely easier, although this should be a minus sign. It's a little easier to think about that one in that way. How many committees of at least 4 guys are there? So again, we have to do our men, women. We could have 5 men, no women, 4 men, 1 woman, 3 and 2, 2 and 3, 1 and 4, 0 and 5. At least 2 guys. So here we have 18, choose 5, times 12, choose 0. That's easy, that's 1. Plus 18, choose 4, times 12, choose 1. Whatever that works out to be. If we want to do it for this one for F, how many committees consist of at least 1 female? I got that wrong. I'm doing circling at least 1 man. At least 1 female. I really don't want to do 5 calculations. So in this case, I'll take the total minus what we're trying to avoid, which is no women. So again, the total here is 30, choose 5. Minus, we would have 12, choose 0 for the men, 12, choose 0 for the women, times 18, choose 5 for the men. Much easier than doing 5 separate calculations for that. Okay, so the problem solving, we're just introducing another tool that you can use. If you're comfortable with all the tools, it's better. If you are only wanting to simplify it down to 1, use arrangements with repetitions. That is the one tool that it will work for everything if you do the problem, if you set the problem solving up correctly. Now here, we want to simplify this guy as factorials and then get it as simple as possible. So here, n choose 5. This would be n factorial over n minus 5 factorial, 5 factorial. I am just using our formula from our formula sheet. And then I'm going to do the same thing from down here. I have n minus 1 over n minus 1 minus 3 factorial 3 factorial. That is, I missed a factorial. I'm going to go sideways. I probably shouldn't, but I'm going to. The top is already simplified. I'm going to flip the bottom here. That's going to leave me with n minus 4 factorial times 3 factorial over n minus 1 factorial. Now, we can see that we have a couple nice ones. We have an n minus 4 and an n minus 5 here. We have an n factorial and an n minus 1. So I'm going to expand this guy out until I get to n minus 1 factorial. Leave this guy on the bottom. I'm going to expand that 5 factorial out to 5 times 4 times 3 factorial, and you can probably see why I'm doing that. I'm going to take that n minus 4 and expand it out once. Now, this is a slightly simpler way if you just want to brute force expand everything and just deal with this guy here and simplify it. You're perfectly welcome to do so. There's nothing wrong with that. You just see that I can cross off this n minus 5 with that n minus 5, that n minus 1 factorial over that n minus 1 factorial, this 3 factorial with that 3 factorial. And then all we have left is we have an n minus 4 over 20. Now, if you want to solve this, again, I can't remember if I actually can solve this, but the process would be the same. We are going to replace the combination notation with factorial notation. We have 2 times n factorial over n minus 2 factorial 2 factorial. Now we can already cross off that 2 and that 2. It's 2 factorial is 2. Over here I have n minus 1 factorial over n minus 1 minus 3 factorial 3 factorial. Just tidy this up a little bit. Now, as I said, you can brute force this by doing both sides, and that's what I'm going to do in this case. n minus 1, n minus 2 factorial. I'm done expanding that guy. Over on this side, I've got n minus 1, n minus 2, n minus 3, and n minus 4 factorial. Sorry, ran out of space. Over n minus 4 factorial, although I did manage to misplace a 3 factorial there. So let's put that guy back in. So that guy's crossed off, that guy's crossed off. This one's crossed off with that one. This n minus 1 is crossed off with this n minus 1. They're in the numerator on both sides. They'll cancel. That leaves us with a formula n is equal to n minus 1, or n minus 2, n minus 3 over 6. So bring my 6 over. Okay, and we notice by fiddling around that, we now notice we have a quadratic, a second degree. So 0 is equal to n squared minus 11n plus 6. This is not factorable, so this guy has no solutions. If it was factorable, it would have solutions. Okay. So obviously I really need to fix this because I've done it 2 or 3 years and I forgot to fix it every year. But you see the process. We get down to a non-factorable system here, but we reduced both sides and we got down to here. Hey, that's not factorable, but we are down to a second degree, which we should know how to factor on good days when the teacher doesn't screw up. Okay. And then the last question, Bubba has a collection of 10 paintings. Explain why there are the same number of selections possible if he chooses to display 2 paintings or if he chooses to display 8 paintings. So if he displays 2 paintings, he chooses 2 and leaves 8. So he has a group of 2 that he's putting on the wall, and a group of 8 he's leaving in the storeroom. If he wants to display 8 paintings, he chooses 8 and leaves 2. So he's got a group of 2, or he has a group of 8 on the wall, and a group of 2 in the storeroom. So in both cases, he is dividing up his paintings into 2 groups, one of 8, one of 2. He's displaying 2 in one and 8 in the other, but it's still dividing these guys up in the same. Mathematically, we can see that if we have 10 choose 2, that's 10 factorial over 10 minus 2 factorial 2 factorial, so 10 factorial over 8 factorial 2 factorial. And if he goes 10 choose 8, same thing, 10 factorial over 10 minus 8 factorial 8 factorial, which gives us 10 factorial over 2 factorial 8 factorial. So these are exactly the same. Okay. Other combinations that are exactly the same would be 37 choose 5, and that would be equal to 37 choose 32. These 2 numbers add up to 37. 65 choose 9, God, that's terrible. 65 choose 9 would be equal to 65 choose 56. 9 plus 56 gets you to 65. So again, the combinations are symmetrical. The groups are the same. There's the same number of groups in each of these 2. You build with combination with groups, you build to a peak and then you come back down. With permutations, you just keep going up because order is important. But if order is not important, they come back down to the same number. So tomorrow I will go over some of these questions with you. Thank you for watching, and I will see you later.